Now let us derive integrated rate equation for zero order reaction. Let us consider here the reactant which give product. The rate of this reaction may be expressed as minus change in concentration of reactant upon time taken is directly proportional to R raised to power 0. Why we put R raised to power 0? Because it is zero order reaction. On removing proportionality sign, assign some constant, say K, that is velocity constant. So we get K. Here the something raised to power 0 have one value. On that, on simplification we get minus K gt. Now on integration both sides, we are integrating both sides, we get integration cancel out differentiation. Here the R remain and here we have Kt plus C. Here the C is the integration constant. Now at time t is equals to 0, at time t is equals to the value of R is equal to initial value, that is R naught. Put in above equation, we get R naught is equals to minus K into 0 plus C. There implies C is equals to R naught. Putting the value of C in equation number 1, we get, from equation 1 we get R is equals to minus Kt plus R naught. Now transposing Kt to left hand side, we get R naught minus R. Thus the value of K comes out to be R naught minus R upon T. That is a relationship between the velocity constant, time and concentration of reaction. At half lifetime, the value of T is substituted as T half and the value of R equal to R naught by 2. Substituting in the above equation, we get K is equals to R naught minus R naught by 2 divided by T half. Thus on simplifying, we get the value K is equals to R naught upon 2 T half. That is the relationship between the velocity constant and half lifetime for reaction for zero order reaction. If we plot a graph between the concentration of reactant and the time, we will obtain this type of line. The slope, the value of slope is equal to K minus K, because it is in decreasing manner. The K is equals to minus slope, and this intercept indicates the value of R naught, that is initial. It should be noted all the enzyme catalyzed reaction obey zero order kinetics. Also the reaction take place on metal surface obey zero order kinetics. Now let us summarize. Firstly, suppose we have R gives P, rate of reaction may be expressed as minus dr upon dt directly proportional to R raised to power 0. Something raised to power 0 here we taken because it is zero order kinetics. Something raised to power 0 has 1, so minus dr upon dt is equals to K. Here the K is the velocity constant. On integration both sides we get R is equals to minus Kt plus C. At time t is equals to 0, the value of R is equals to R naught. Putting in above equation, we get the value of C is equals to R naught. By putting the value of C in equation number 1, we get the relationship A is equals to R naught minus R upon T half. At half lifetime, the value of T is equal to T half and the value of R is equals to initial by 2. On putting these values in above equation, we get the final relationship between the K and T half. It is K is equals to R naught minus R naught upon 2 T half. All the reaction take place on metal surface obey zero order kinetics. Also enzyme catalyzed reaction obey zero order kinetics. Now let us derive integrated rate equation for first order reaction. Here we derive zero order reaction. Now let us derive for first order reaction. Student, For driving integrated rate equation for first order reaction, let us consider a reaction R gives P in which reactant gives product. It is first order reaction. The rate of reaction is expressed as minus dr upon dt directly proportional to r raised to power 1. Why we put 1 here? Because it is first order kinetics. On removing proportionality sign, assign some constant, say k. Now we have minus dr upon r is equals to k dt. On integration both sides, on integration both sides we get minus log base er, because integration of minus dr upon r is equal to log base er is equals to kt plus c. Here is equation number 1. At time t is equals to 0, the value of r is equals to r naught. Put in the above equation, we get minus log base e r naught is equal to c. Now putting the value of c in the above equation, we get from first, when we put the value of c in above equation, we get minus log base e r is equal to kt minus log base e r naught. Substituting this value to left hand side, we get log base e r naught minus log base e r is equals to kt. Thus the value of kt comes out to be log base e initial upon final. Now we are converting log base e to log base 10 by multiplying it with 2.303. Thus we have a relationship k is equals to 2.303 upon t log base 10 initial upon final. That is the relationship between the k and t for first order reaction. For half-life time, we are putting t as t half and the value of r is r naught by 2 in above equation. We on simplification we get 2.303 upon t half log base 10 r naught upon r naught by 2. On simplification we get the final relationship. It is 0.6931 upon, that is the relationship between decay constant and half-life time for first order reaction. On solving this, we get this final relationship. If we plot a graph between log base er versus time, we will obtain this type of graph. The value of k is equal to slope and this value indicate the initial value, that is log base e r naught. It should be noted all radioactive and the artificial radioactive reactions obey first order kinetics. I repeat again, integrated rate equation for first order reaction, rate is directly proportional to the reactant raised to power 1. On simplification, we get the relationship between k and t. It is k is equals to 2.303 upon t log base 10 initial upon final. Half-life time we put t as t half and r as r naught by 2. On solving, that is a final relationship between the decay constant and half-life time for first order reaction. Now let us solve integrated rate equation for gas phase reaction. Now we are solving integrated rate equation for gas phase reaction. Integrated rate equation for gas phase reaction. Suppose we have a gas which produce B and C, which is also in gaseous state at time T is equals to 0. Suppose initial pressure is Pi, these are not formed. At time T, suppose x bar of this and x bar of this are formed, then Pi minus x of these are decreased. Now, the total pressure may be obtained by adding the partial pressure of these one, that is Pi minus x plus x, cancelling x by x, and Pt is equals to Pi plus x. Thus the value of x comes out to be Pt minus Pi. It is Pt minus Pi. Gives equation number 1. But partial pressure at A is equal to Pi minus x, and x value we calculate in equation 1. It is Pt minus Px put here. Then Pa is equals to Pi minus Pt minus minus plus Pi. Thus the value of Pa comes out to be twice of Pi minus Pt. We have equation K is equals to 2.303 upon T log base 10 initial pressure upon final pressure, that is K is equals to 2.303 upon T log base 10 Pi upon twice of Pi minus Pt using 2. So that is the relationship between, it is the integrated rate equation for gas phase reaction. Suppose we have a gas which give B gas and C gas at time T, initial pressure is Pi, these are not formed at the instant of time T. Suppose x of B and x of C are produced, and so Pi minus x of A are decomposed. Then Pt is equals to sum of these. On solving the value, get x, but partial pressure of A is Pi minus x, put the value of x here, we get Pa is equals to twice of Pi minus Pt. Putting these value in this formula, we get the relationship, that is the integrated rate equation for gas phase reaction. Now let us discuss pseudo first order reactions. Those chemical reaction which appears to be bimolecular but obey first order kinetics are said to be pseudo first order reaction. I repeat again, those chemical reactions which appears to be bimolecular but obey single or first order kinetics are said to be pseudo first order reaction. It is due to the axis of one reagent. The best example is inversion of sugar. Suppose C12H22O11 on adding water produce C6H12O6 and C6H12O6. Here it is glucose and it is fructose. Now the rate of reaction dependent only on the concentration of sugar, that is C12H22O11, not on water because water in excess. So pseudo first order reactions are those which appears to be bimolecular but obey first order kinetics due to excess of one reagent. Thank you very much.